Welcome to Morsteam's tutorial video on conducting a logistic regression in EngineRoom. Logistic regression is used to model a binary outcome, such as success or failure, from a set of independent predictors. In this video, we will analyze two datasets, one in raw and the other in grouped format, and we'll explain these terms as we go. Let's first examine the raw data. An insurance company wants to determine at the 5% level whether or not a customer will renew their healthcare plan based on three predictors: the price differential of the current plan compared to the market benchmark, customer satisfaction ratings on a scale of 1 to 5, and the level of coverage labeled bronze, silver, and gold. The response is renewal, coded 1 if the customer renewed their plan and 0 otherwise. Such data are called raw data because they show the individual level response for every customer in the study. If we had instead combined the customers into groups, say by region, and analyzed the number of renewals across regions, then we would be dealing with grouped data. Let's analyze the data. Go to the Analyze menu and under Regression Analysis, select Logistic Regression. We're not using the guided mode, so all the available drop zones show up simultaneously. If the guided mode is switched on, you will see the additional drop zones and subsequent steps as you progress through the dialog. To run the analysis, click on the raw dataset and drag each predictor variable onto the independent variable drop zone, noting that as you attach one variable, another drop zone becomes available. After attaching price differential, customer satisfaction, and plan type onto the study, you can drag the binary response renewal onto the response variable drop zone. At this stage, you're ready to move forward. Leave the default significance level at 5% and click Continue. Let's examine the model output. The response information shows that there were 51 renewals and 72 non-renewals for a total of 123 customers. The final model information shows the model equation and its log likelihood value, which can be used to compare different models. The larger the likelihood, the better the model. The estimated response model table shows the regression coefficients for the terms in the model along with the standard errors, z-test statistics, p-values, and the lower and upper confidence interval limits. We see that price differential and customer satisfaction with low p-values are significant, while the plan type is not. However, let's retain plan in the model in order to predict renewals for each plan type. The next table shows the odds ratios. Recall that an odds ratio less than 1 means that the event, in this case renewal, is less likely as the value of the underlying predictor increases. An odds ratio greater than 1 indicates the opposite, that the odds of renewal increase with the predictor variable. So we see that the odds of renewal decrease slightly as the price differential increases with respect to the benchmark, and the odds increase by a factor of 4 times as satisfaction increases by a single rating. For the coverage level, the odds of renewal for a gold plan are less than half the odds for a bronze plan, but the odds of renewal for a silver plan are 2.8 times the odds for a bronze plan. In short, it appears that customers are much more likely to renew a silver plan than either gold or bronze. The company may want to investigate the reasons for this preference of the silver plan type. The test of model fit table shows that the overall model is significant. The 3 goodness of fit tests evaluate model fit, and the large p-values we see here indicate a good fit. The multicollinearity table shows the variance inflation factor, or VIF, values for each predictor. Values above 5 or 10 indicate moderate or strong multicollinearity, respectively, among the predictors. Since all the VIF values are below 5, we can safely say the predictors are not highly correlated amongst themselves. And finally, the 3 residual plots show residuals from predicting the zeros and the ones in the data, so we're looking for outliers that fall far from the lines depicting these 2 responses. While there may be potential outliers in the top 2 graphs, the plotted points are generally close to the bulk of points, so we can conclude that the model is a reasonable one. Now that we've done an analysis of the logistic regression data in raw format, let's take a look at the grouped format data. In this case, a hospital wants to predict at the 10% level whether or not a patient with a certain chronic condition will present for follow-up based on the patient's perception of the severity of the condition and whether or not the patient has a previous history of the condition. The follow-up column shows the number of patients presenting for follow-up. The total column gives the total number of patients corresponding to each unique combination of history and severity, and the two predictor columns show the levels of history as 0 or 1 based on whether they have the condition, and severity as 1, 2, or 3, with 1 indicating low severity and 3 the highest level of severity. Such data showing counts of a binary outcome in groups are said to be aggregated or grouped. To analyze the data, once again open a new logistic regression study and drag the two predictors, history and severity, onto the independent variable drop zones. Next, drag the follow-up response variable onto the response variable drop zone and the total variable onto the group variable drop zone. Change the significance level to 0.1 and hit continue. The output is very similar to the last one. We had 133 patients present for follow-up and 69 who did not, for a total of 202 patients. We see that both history and severity are significant at the 10% level. Looking at the odds ratios, patients with a history of the condition have a 1.7 times greater odds of follow-up over patients who do not have a history. Similarly, patients who perceive their condition to be more severe have 1.5 times higher odds of follow-up compared to those who feel it is less severe. Moving on, the whole model test is significant, and the goodness of fit tests indicate a good fit. The residual plots are difficult to interpret with only 6 predictions, so we won't interpret them, but the output generally supports the model. So this was a demonstration of logistic regression for a binary response using both raw and grouped data. We hope you enjoy analyzing the data using EngineRoom on your own.